All right, so we learned that way back in section 9.2. Now the new ones that we've learned in chapter 11. So we have the, oh, fiddle faddle. I meant to have this be color coded. Hold on, let me rewrite all that in green. 1 second. There you go. I meant that to all be color coded just to help you guys. All right, so then, oh, and apparently my hand has gotten smudged. Oops. Okay, so now here, the other two new ones. So we learned section 11.2. I'm going to kind of put these in a different color. So this was 11.2. This was for the difference. It's a, well, let's see what I titled it. It's an interval for the difference in a matched pairs setting, right? So it's the mean difference of a matched pairs group. All right, so it's a matched pairs mean. Which is on page 274. Right? It's the second box on 274. So if this one up here was the first box, right? So page 274, the first box was for that one. Then this down here is 274, the second box. Right? That's box, B-O-X. Sorry, that's so small. Okay, so what are we going to look for? Well, the thing is, it's going to have a dependent group. And this is really the only one that's going to have a dependent group, right? So you're really going to look for a dependent group, right? Where you have pre and post, before and after, husband and wife, right? Things where they're not two separate independent groups. So if you have a dependent group, then it's going to be this one, right? So think pre/post, for example. I'm just going to put EX above that, right? So if it's pre and post, that's a dependent group. All right, now what's the parameter we're measuring? What's the parameter we're making an interval for? Well, it's for the mean of the differences, right? So I didn't state it right there because I honestly didn't have space for it on the sheet, but it's mu d. It's the same value that we talk about when we talk about hypothesis tests for this value. So if I go to the hypothesis test, you can see it. It's mu with a little d after it because it's the mean of the differences right there. That's what you're making a confidence interval for. So it's the mean of the differences for that matched pairs group. So it'll be mu with a little d after it. All right, now to be normal is very similar to the one above, actually. So if I go grab I'm just actually grab the sheet. I'm tired of fussing with the paper. All right, so right here. So to be normal, you need 4 things, right? Oh, excuse me, 2 things, 1 thing right here. So it's the same as it was before. Sorry, it's a graph or n greater than 30, or I could just give it to you. I mean, if I state that it's normal, then that's fine. So sorry, this is exactly the same. I was thinking about the next section, but this one's exactly the same. So as the one above. So that's nice. So it has the same thing. So it's given, graph, or n greater than or equal to 30, just like the one above, right? These two are very similar to each other. The trick is that this is a dependent group. So you end up making one group of the differences, right? So it's one group, but it's of the differences of that group, right? Now for technology, again, it's right there on the page, but you can see it. So let me bring it up. It says it right here. So you enter the raw data into 2 columns, and then you do stat, t-stat, to sample. Oh, I don't think that's right. I think that's a typo. Oh, I'm looking at the wrong one. There it is. I was like, that's not right. There it is. Paired. There it is. Stat, t-stat, paired, because this is for the differences, the matched pairs differences. This is the one right there. All right. So, and then it's kind of involves for the TID4. You're doing a t-interval, but you're doing it on those differences. Again, everything about this particular one is that it's on those differences for that dependent sample. So I guess I should say, look for differences, and I'm just going to write differences up above. Right, it's that dependent group, but it's really the differences of that dependent group. And then for technology, we're going to go stat, T stat paired, like that. And then if you're on a TID4, it's a T interval again, but it's the T interval of the differences. And I'll just write that. P interval of the differences. So you'll have to find those differences first. All right, now the last one, the one I was trying to do a second ago by accident, is section 11.3, which is for the difference of two means. Just like this one up here was the difference of two proportions, right, for independent group. This is for the difference of two means, which is on page 274 as well, but it's the last box on that page. Sorry, that word box right there is bugging me because it's still really small. So let me make it bigger. Box. There we go. That's a little bit bigger. All right, so it's the last box on page 274. Okay, so what are you going to look for? Well, before I even get there, let's talk about the parameter. So it's mu1 minus mu2, just like it is for when we do a hypothesis test of this. So it's for the differences in the population mean. And for the record, this one right here is for the mean of dependent difference, right? They kind of work differently than each other. This one you find all the differences first, and then you're trying to talk about the mean of those differences. And this one is talking about the difference in the population means, two separate groups. So this one, you're going to look for, well, quite frankly, two separate groups, right? So it's the average, it's the mean and average. So you'll see the word means in there. You'll see average in there. You'll see standard deviation flying. If you have data tables, right? So it'll be two data tables. You'll have to have one for each group, as opposed to this one, which is really one data table, but with two columns in it because there's a pre and a post. This one's two data tables because this is all for two separate groups. Oops, I should write the word out. Sorry. All right, now to be normal, again, just like above here, we could have it given to us, which it almost never is. We could have graphs. You actually need two of them. You need one for each group, right? Because everything here is about two separate groups. So you could have given, you can have it graphs, there'll be two of them, or you could have n1 bigger than 30 and n2 bigger than 30. You need both of them. For technology, that would be stat. Oop, I don't know why I'm writing in blue or black when I meant to write in blue. So to be stat, and this is the one I showed earlier, stat, t-stat, it'd be two samples, right? So two samples. And then you're going to have to choose, here, I'll go here, data or summary. It just depends on what you're doing. Right? If they give you two separate data tables, then you can do the data thing. If they give you a big paragraph with everything written out, then you'd have to do summary. It just depends on what they're giving you. So that's stat. And again, those instructions are on page 274. Now, if you're on a TID4, that would be 2 samp T int, int. But if you're not on a TID4, then don't worry about it. All right, that's a lot. We got a lot to keep track of here. Okay, so then there are some things that we learned in chapter 9 that we still have to keep track of for now. Okay, 1, the alpha and the sea level are complements of each other, right? Meaning they add up to 1. The interpretation piece, we are still the sea level percent confident that the true population parameter, and you'd still have to talk about this using context. So you'd still have to write with context about what you're talking about. And if you're thinking about what parameter is it, well, it depends. That's what I was talking about up here, right? With the difference in population means and the mean of the dependent differences and so on. Technically, this is the population mean, I should say. Population mean of dependent differences. All right, confidence intervals always follow a basic formula, right? Okay, so, and that leads us to a whole bunch of other things. So the confidence intervals always follow point estimate plus or minus margin of error. And that leads to 2 formulas that we've learned before, but I'm going to say them again. The point estimate is the lower plus the upper, add them up, divide by 2. The error is the upper minus the lower, divide by 2. Sorry, my arrow in there got weird. So I'll just say, right? Oops, I have a stray mark right there. All right, so that happens because of this, right? So the fact that the point estimate plus or minus the margin of error is true leads to these 2 formulas. You can only use them if you know your confidence interval, but a lot of times we do know our confidence interval, so that's true. So those things all fall hand in hand. Next, we've learned that the sample size and the sea level, or excuse me, sample size and the margin of error have a relationship. And it's an inverse one. So I'll just put it right here. If the sample size goes up, the error goes down, right? And vice versa. They have an indirect relationship or an inverse relationship. If one goes up, the other goes down. That is the nature of that beast. Then if confidence goes up, if your sea level goes up, then error goes up. Those 2 have a direct relationship. Similarly, if confidence level goes down, error goes down. Right? And then standard deviation. If your S, which is standard deviation, goes up, or your standard error, right, this SE, that's fine, then your margin of error goes up. Right? Those have direct relationships. So these 2 are direct relationships, and this one is the weird one. This is the one to watch out for. That's an indirect relationship. Or inverse, I guess I should say. It's an inverse relationship. That'll be easier to remember. And that's the weird one. Or the one that's unexpected, so I say. And then, of course, what we learned in Chapter 11, which is very important, because in Chapter 11, we're always assuming that the null hypothesis is that one value equals the other value, right? So P1 equals P2, or the difference is 0, or, right? If we think about Chapter 11, these were the possible null hypotheses. Mu1 equals mu2. You're always assuming equality. So if 0 is not within the interval, that implies that there is a significant difference, and we reject H naught. Right? When there's a significant difference, we reject H naught. If 0 is within the interval, that implies there's not a significant difference, which means we do not reject H naught. H naught stands. We said it multiple times in Chapter 11, but it's still true and it's still worth remembering here.